Hey guys, welcome to Calculads. Today we're going to be going over Unit 5, which is curve sketching and analysis of like graphs and stuff. So, first thing you need to learn is the extreme value theorem. For this, it says that if a function f is continuous over the interval ab, realize it's closed, so it includes the endpoints as well, then f has at least one minimum and one maximum on that same interval. So you have an interval, there has to be at least one maximum and one minimum. A critical point is just a function, or is just a point on the function where the slope at that point is 0 or it doesn't exist. So we need to talk about the applications of the derivative in graphing. So the first derivative, we've learned already that means a slope. We know that when the f prime is positive, f is increasing, positive slope, it has to go up. When f prime is negative, f is decreasing. So when slope is negative, it goes down. And we can also use that to find the minimum and maximum values of a graph. So when we find the minimum, we know that f prime has to go from negative to positive, and for the maximum, it has to go from positive to negative, and it has to switch signs. If you need to check for that, and it might go from positive to positive, if that can happen sometimes. And when that happens, it's not a maximum, so you have to check both sides. And the second derivative is concavity, which is like up like a cup or down like a frown. So it has like a little U shape that it makes. When f double prime is positive, f prime would be increasing, so the slope is getting more and more and more steep, which makes that cup shape, and that means it's concave up. When f double prime is negative, then f prime is decreasing and concave down, so opposite of what I just did. And we also learn of the point of inflection, which is the x value where the concavity changes, which means that f double prime would change signs. So here we have the function f of x is equal to e to the x minus x cubed. We're going to find the critical and inflection points. So if we're looking visually at a graph, the critical values would just be when the slope is 0. So like here, here, and here. When it's a little less obvious to see are the inflection points where the curvature changes. So here and here, where it goes from up to down, back to up. And you can also solve for this using calculus. So if we take the derivative, we get e to the x minus 3x squared. If we set that equal to 0 to find the critical values, we get, for this one, x is equal to negative 0.459, 0.910, and 3.733. And you can check for these values here using what's called the candidates test. So you plug values into f prime, where you just plug a value that's in between these specific critical values, and you can then see if it's negative, positive, negative, positive. You don't actually have to find out what the number is, you just have to find the signs. And so when we know that negative goes to positive, that means it's a relative minimum, and for positive to negative, we know that it's a maximum, which is how we find these values and know what they are. For the second derivative, we take the derivative again, we get e to the x minus 6x, set that equal to 0 to find the inflection points. So we know the inflection points for this are at 0.204 and 2.833. And then we can use the candidates test to see if it really is an inflection point. And we see that it goes from positive to negative, back to positive. So we know it switches signs, and we know that those are inflection points.